Hi friends, today my topic is radiography test. Radiography test is one of the important tests carried out in industries to find out the defects of the joints of metal parts, especially welding joints, and once it is giving very accurate defects and their nature, but at the same time it is very harmful. So let us see uh, what type of defects and how this radiography test is carried out. First of all, for radiography test, the arrangement has to be made like this. There's this container for taking the source, and this container is taken to the site by means of a particular vehicle, and the area is being barricaded, and the sample piece has been, as here is shown the sample piece. The film is kept on the opposite of the collimator. This collimator is the device, and the film is here. It is film has been put and collimator has been put. This collimator is connected to a tube to the source, and this source container is again connected to the electrical point, which is kept far away. And this electrical once you press this electrical button, the source will source will blast out, and the radiography will start, and you can measure by means of a stopwatch also. Okay, this now uh, next figure we'll see how it is happening through a film. This film is this is the, here it is sample, here it is film, here it is sample, right? That's the source. So source is delivering the rays or radiation, that is gamma rays, beta rays and alpha rays, and this passing through the defects of the metal undeflected and putting the spot on the film. And if it is since they are the undeflected, they will give them more amount of darkness and on the film, and accordingly you will find the defects in this type of film as produce. For porosity you will find like this, for cracks you will find film like this, and for slag occlusion, for transparent occlusion and drop you can find out. And this film can be visualized through light box, cafetiere, and yes is the nature of film. There are three coatings. One is protecting layer, and second one is emulsion coating or absorbing coating, and third one is transparent coating or polyester coating. These three layer coating of the films are kept. Okay, now we know in this radiography generates lot of harmful radiation like gamma rays and beta rays, and only some limited portion can be tolerated by body, like a maximum it can be 50 rams or 500 millisievert. Here in this picture you can see in 3 weeks there's a rashes, but in 6 weeks it can be very dangerous. And in this case you will see whole body can tolerate up to 5 gram or 50 millisievert, maximum 50 RAM is allowed for extreme regulatory limit, that is called. Thereafter all sort of things start happening like dodginess, vomiting, nearby 100 grams, and nearby 400 to 500 grams 50% people will die, and like this it will be, the consequence will be very dangerous. It is will start from hair loss, permanent infertility, and cataract, skin cancer, etc. So what are the safety devices can be used for this? To remove this effect we use so many safety devices in the radiation. First of all, collimator. Collimator is the device which use to save or prevent the scatter of the radiation, and this is the collimator. And surveymeter. The surveymeter is used at the source or near the laboratory to know the levels of radiation around, and operator also wear film badges having the particular crystal coating badge, which is generally gray in color, but if it is exposed to the radiation it become black in nature. TLD badges also used, which is giving illumination or glowing if it is exposed to the light, exposed to the radiation. Beside this stopwatch is used to know the time limit, because that's from the source to if it vomiting start that time. If it is time is less, then vomiting will time less time, that means exposure is more. So we can identify how much exposure is there. Now you should know how far away you have to put the barricade so that nobody should enter into the radiated zone. For this, there is a inverse formula d1 square into r1 equal to d2 square into r2. Either d1 is the, for example, I am taking 20 curie of iridium 192. Here d1 for 192 is dose rate at 192, it is 4.8 meter, 8 milligauge, or you can say millisievert, and this is safe near 7.5 microsievert per hour. So we have to put the barricade near where this 7.5 microsievert radiation is there. So your D2 has to be R2 is the 7.51 and D1 is 1 meter, and it is dose rate at 1 meter is 4.8. If you put for 20 curie, it will be like this, and R1 will be like this, D1 is this, so R2 this. So if you put this, it will be 113.14 meter. From this we have we can make one chart like this, and 5 curie, 8 curie and 10 curie, and how much exposure is there, 5 hours per week or 30 hours per week. Accordingly your distance of irrigation will be varying, and it also depends on the nature of occupancy. For example, 10 curie, if it is 20 hours per week, 100 meter away you have to put the barricade for full occupancy. Okay, so I think you understood how to take the precaution and what are the effect of radiography test. So this will help to maintain the radiographic safety hazards at industrial working area. Thank you for watching. If you like it, leave comments and share it. Thank you. Hey friends, today my topic is radiography test. Radiography test is one of the important tests carried out in